Hello everyone, my name is Badr and I'm here to teach you how to build your first Android application. This course is divided in two parts. The first part consists of basics of Kotlin. The second part is the Android application that you are going to build. So without further ado, let's jump right in. So first of all, what is Kotlin? Kotlin is a statically typed programming language introduced and developed by JetBrains in 2011. In 2017, Google stated Kotlin as the official language for building Android applications. So why Kotlin? Kotlin is a cross-platform for mobile, which means that we can target both mobile, Android mobile applications and iOS mobile applications. We can also develop by Kotlin web and server apps, as well as desktop applications. Kotlin is suitable also for data science-based applications, so Kotlin does it all, you name it. Kotlin will do it for you. So if you are familiar with the basics of Kotlin, you can skip to the second part of this course. To write and to test our Kotlin code, we're going to need something called an IDE. So IDE stands for Integrated Development Environment, which is basically an advanced text editor that consolidates basic tools that can help us write and test our Kotlin code. We will install the IntelliJ IDEA IDE by going to the official website of JetBrains. So JetBrains is the company that developed Kotlin, and it develops also the text editor or the IDE for Kotlin. So we're going to choose the community version, which is free. And after downloading and installing the IDE, it's pretty simple. After downloading and installing the IntelliJ IDE, open the IntelliJ IDE, and a new window is gonna pop up. So this is the window where we're going to create our first Kotlin project. So let's create a new project. Let's name it, for example, basics Kotlin, for example, and type or click create. So in the main package, or in the main package and in the Kotlin package, let's create a new file. Let's choose here file, and let's name it main.kt. So in this main file, we're going to add something called the main function. So in every Kotlin program, we do have something called main function. So this main function is the function responsible for executing our code. So if we typed, for example, here print line my first Kotlin app, and if you click here in this icon, the program will be executed. So this is your first Kotlin program. So without the main function, we cannot run our code. In the bottom of the screen, we have this area is called the output of the console. In the output, we have the message that we wrote, my first Kotlin app. So basically everything is working fine. We don't have any error. And I forgot to mention something. If you don't have the JDK, the Java Development Kit, installed in your computer, you can download it from the website just by typing adopt JDK, and you can choose here the latest version of the JDK, and you can install it. In Kotlin, we have two types of variables. The first type is mutable. What does it mean? Its value can be reassigned. Let's see, for example, this variable So in order to write a variable, we have to use the keyword var followed by the name of the variable. Let's give it the name quota, and we can explicitly specify the data type. And the supported data types in Kotlin are numbers, character, string, boolean, array, ranges, etc. So quota will be of type double, and let's give it the value 0.25. So this is a mutable variable, which means that we can reassign the value to another one. Let's give it, for example, 0.35. So we do have the right to reassign the value of the variable. So we can remove the explicit data type specification, and it's correct. Why? Because the compiler understands that the quota is a double variable. The opposites of mutable variables are the immutable variables. Let's take the following example: first and last name. Let's give it a value of Mike Bigham. So your name can't be changed. So the first and last name is immutable variable, which means that we are not allowed to reassign another value to it. This is why it's called immutable variable, and the compiler is complaining about this operation. So this is basically the two types of variables that we have in Kotlin. So in order to write an acceptable name of the variable in Kotlin, not even in Kotlin, but in any other developer language, we need to use something called camel case. So what does it mean, a camel case? It's a typography to write names of variables. It consists of putting the first character of the first word in lowercase and each first letter of the rest of other words in uppercase. For example, the first word here is first, so the first character will be in first lowercase. The rest of each word and the first letter of each word will be in uppercase, and so on. So and will be in uppercase. Last, the first L will be in uppercase. Name N will be in uppercase, and the rest is in lowercase. This is just a convention by developers. In Kotlin also we have something called comments. So a comment is something that will never be executed by the compiler. So in order to write a comment, we need to use / followed by the content of the comment. So basically, why we need to use comments? For example, if you are a developer working with a team of developers and you have coded a specific algorithm containing multiple steps, and if you want to make those steps understandable to other developers, you can use comments to make your code understandable. Because if we execute here this code, this line of code will never be executed. Why? Because it's basically a comment. So a comment, it's used for to make your code understandable if you want to explain something to your colleagues. So Kotlin arithmetic operators are used to perform mathematical operations such as addition, subtraction, multiplication, and division. We do have the addition operator, which adds together two values. The subtraction operator subtracts one value from another. We have the multiplication operator, which multiplies two values. We have the division operator, divides one value by another. And we have the modulos operator, which returns the division remainder of two numbers. The relational operators basically a comparison operators are basically used to compare two values and return a Boolean value, whether true or false. So the supported operators are greater than, less than, greater than or equal to, less than or equal to, is equal to, not equal to. The logical operators basically determines the logic between two variables or values. We have three types of operators. The first one is logical AND, which returns true if both operands are true. Logical OR, which returns true if either of operands is true. And we have logical NOT, reverse the result. So if the result is true, it's gonna give us false, and if the result is false, it's gonna give us true. We're going to talk about a very important subject in Kotlin, which is control flow. So what does it mean, control flow? Control flow is how to determine the next code to be executed. Simple as that. So we distinguish between two kinds of statements in Kotlin, how to basically to execute a code depending on a certain condition. So the first statement is if else statement. So how we using if else statement in Kotlin. It's very simple. Let's declare a value. Let's call it is legal. And let's give it a value of false. So this is our condition. So the syntax of if else statement is as follow. We do if, and inside the parentheses we enter our condition. So our condition right now is legal. If legal is true, we're going to print to the console this message. Let's say you can vote. Otherwise, let's print the following message to the console. You cannot vote. So this is how we use if else statement. So it's pretty simple. The second statement, which is when. So how are we going to use when? It's easy. So we are going to achieve the same thing with if else statements by using when. So the syntax is as follow. We use the keyword when. We open the parentheses, curly braces, and inside the parentheses we put here our condition. In our case, the condition is legal. So the condition is always giving us a Boolean result, true or false. So is legal. We distinguish between two cases. If is legal is or if is legal false. In case of false, we will print the following message. Sorry, now my writing abilities is bad right now. You cannot vote. And or when we have a true result, we will print the following message. You can vote. So right now we achieve the same thing by using if else or when statements. So if you are familiar with other developing languages, the equivalent of when is a switch in Java or in a PHP. So let's execute our program, and of course it's gonna give us the same result because we did pretty much the same thing. So you cannot vote. The first result is for the if statement because is legal is false, and you cannot vote. For the second is we have is legal is false, so it falls into this category where we have this message. So I hope you understand if else statement. I'm not going to enter in details about other examples, so this is a simple example to understand. Another way how to control the flow or how to control the statements in your program is using loops. So loops are often used when working with arrays. So let's declare here an array. Let's give it, for example, let's give it the following value. I have prepared the value in advance. So let's call the array valid numbers. It's a list of 4 items, 1, 2, 10, and 15. So as we said before, we use loops often when working with arrays. So right now we have an array. It's called valid numbers. So if we want to show all the elements of the array, we need to use the loop. So how to use in loop? We have the first statement is for. So the syntax is as follow: for, open the parentheses, and for item in a collection, and the collection that we have right now is valid numbers, and we open the curly braces. Inside the for loop statement, we put our code that we want to work with. So what we are going to achieve is how to print. We're going to print every single element of the array. So it's going to be print line, and we will write as follow: element, the element $, and the element is represented by the item value or variable. So the element item belongs to valid numbers array. And if we execute our program, we're going to have 1, 10, 1, 12, 10, and 15. So the element 1 belongs to valid numbers array, and so on. We can achieve the same thing by using the while statement. So there is a difference between for and while, of course. We will declare here, first of all, a variable. Let's call it index, because we are going to need an index in order to access each element of our array. Going to give it the value 0. Just keep in mind, the index of an array starts from the 0 value. So, for example, in this list, we have 1, the index of 1 is 0, the index of 12 is 1, the index of 10 is 2, and the index of 15 is 3. We have 4 elements, but we start the index counting from 0 to the number of elements minus 1. So the syntax of while is as follow. We put the keyword while, and we open the parentheses. Inside the parentheses, here we have the condition. So our condition, it's gonna be when index is less than valid numbers point size. So we're going to loop over the array, and the condition, it's gonna be the index inferior than the size of the array. As we said before, the size of the array here in our example is 4, so we're not going to include 4. If we include 4, we will fall into an exception of the index is out of bound. So here we will print the following message. We're going to copy this message here, and the element, so right now, how are we going to access each element? So to access each element, let's declare here a temporary value. Let's call it element, and the element, it's gonna be the valid number, and we will open this braces, and we will put here our index. So we will show right now the element of index 0. And here we will do $ and element. So the element belongs to the to valid numbers array. And of course, after each iteration, we're going to increment the index by 1 step. So let's execute our code. We will have the same thing because I'm going to explain a few things here. So in order to put or to access an element, you need to use the name of the array followed by the braces, and inside the braces you have to put your index. So it's not the same as for, because in for statements we have the item variable. We store each element in the item variable, but here we have to access each element by its index. And after each loop or after each iteration, we're going to increment the index by 1, and we're going to test. So this is how while is working. We test, first of all, we test if the index is inferior than the size of the array. We do our stuff, we execute, we increment the index, and the compiler will return here and test the condition. Condition satisfied, it's going to execute this block of code, and it will loop again. It will test the condition is satisfied, and it will stop until the condition is not satisfied. So this is the second type of how to execute loops. Now we can achieve the same thing, of course, by using another technique, which we call it do while. It's the same thing as while, but there's a major difference. So let's initialize again the index and let's give it 0. And the syntax of do while is as follow. We start with the keyword do, we open the parentheses, and here we put while. So if you might ask, what's the difference between do, while, and while? So you have to be very careful when you are using do while or when you are using while. So I'm gonna give you a simple example or the simple reason why you have to be careful. So if your code has the necessity to test first of all the condition, then doing certain code or certain task, then you have to use while. But if you need the iteration to be executed at least once, you have to do while. That's what we're going to do right now. So pretty much it's the same thing. We're going to copy paste the core of while to do while, and here the condition, it's gonna be index inferior than the valid numbers, the size of the valid numbers. So if you may ask, what's the difference? So the difference is pretty simple. Here in while, we test the condition, then we execute the code. So perhaps we will never execute the code because perhaps the condition won't be satisfied. But in do while, it's different. It can be unsatisfied condition, but at least you're going to execute the code once. So that's the difference between while and do while. So basically, this is how to use loops in Kotlin. So as we said before, loops are often used when working with arrays. So an array belongs to a collection. So we're going to talk right now about collections. So what does it mean, a collection? A collection is a number of objects of the same type. And we distinguish between two types of collections, immutable and mutable collection. So we're going to delete everything in this file. And let's start with the first type of collections, immutable collections. So as the name and the type suggest, immutable, which means that we cannot delete or add or replace any elements. So how to use how to declare a mutable collection? Simply use the keyword val. Let's call it, for example, valid numbers equal. I'm going to use the helper function lists of, and here inside the parentheses, we'll put our elements. Let's say, for example, 2 and 3, 8 and 10. So right now we have an immutable collection. So it's a collection that we will never be able to replace an element or delete an element or add to it. or to add an element to it. And if you, by any chance, do, for example, valid numbers and point to access the available methods for these objects, as you can see here, we don't have any single method that's talking about deleting element or replacing an element or adding an element. So if you declare an immutable collection, that's it. It's gonna be of a fixed elements. The other type of collections, which is mutable collection. A mutable collection, it's a collection that we can basically add to it a member, an element, or to delete from it an element, or to delete or to replace an element from it. So how to declare the mutable collection? Simply use the keyword val, and let's say, for example, and let's call it, for example, students. So we have a mutable list of, so we create the objects using the helper function, mutable list of. So this is a mutable collection. The first element's Mike, the second element James, Celia, and Hannah. So if we try to access, of course, the available methods of the students object, students point, and of course we have another method. So we have the method remove, so we can remove an element from it. We can replace all the elements, we can add another element, and so on. So this is a mutable collection. So this is the main difference between the two collections, immutable and mutable. We have another kind of collection is maps. So maps is basically a collection of key value pairs. So to understand the difference between a map and a normal collection, here in, for example, in the valid numbers, we have 4 elements, and each element is referenced by an index, and that index is a number. So we have 2, the index of 2 is 0, the index of 3 is 1, the index of 8 is 3 and 2, sorry, and the index of 10 is 3. So the indexes are numbers. But in maps, we have the indexes can be, for example, a string index. So in order to create a map, simply use, for example, simply use the keyword val followed by the name of the object. Let's call it employee. And we have 2 ways to declare a map, whether to choose the hash map or the hash map constructor, or to use map off. Let's choose the simplest one, is map off. So I'm not going to specify the type of the index. So the first index, let's call it first and last name. So first and last name is an index, and let's assign this particular index to a value. Let's call it for example Gordon, or let's call it here Mike Gordon. Another index, let's call it age. Let's give it the value 25. And here is another index, address. Let's give it the value, for example, some address. So the difference between a map and a normal collection is the indexes. Here we have an index of type string. We call it a key. And the value here, it's a string. Here we have another index of type string and another value different from a string, which is an integer, and so on. So it has pretty much mixed data with the principle of key value. So this is how to declare a map. And of course, if you want to, for example, to access an element from a collection, a normal collection, as we said before, we put the name of the objects, braces, and let's put inside here the index. We want to access, for example, the index 1. And for the student, it's the same thing, but for employee, let's print, for example, employee here, and let's open the braces, and inside we have to put the exact name of the index. Otherwise, it's going to the compiler or the program is going to give us the null value. So here I'm going to show its first and last name, first and last name. So I have to write the exact name of the index. Let's run the program, and of course it's gonna give us for the first one the tree element, and here it's gonna give us Mike Gordon. So this is how we work with maps and collection. So let's remove this line, and we're going to talk about functions. So what does it mean, a function? A function is a block of code designed to perform specific task. Function can take inputs called parameters, and it has a return value. So the main reason behind using functions is to avoid code duplication and to make our code reusable and shorter, of course. So how to declare a function in Kotlin? Simply use the keyword fun followed by the name of the function. Let's call, for example, the name of the function sum. And here, inside the parentheses, we have the parameters or the inputs that we're gonna call them parameters. So let's specify the first parameter. Let's say a, the first parameter of type integer, and another parameter b of type integer. And here we have the return value or the return data type. If our our function will return void, which means that it doesn't return anything, we're not going to do anything here. But if our function returns a certain data type, here we must put the data type. And of course, we're going to use colon, and using the data type that we're going to return, it will be an integer. So inside the curly braces, we have the core of our function. So for our case, we must return the sum of our two integers, a plus b. So this is how to declare a function. So right now, how to going to use our function. Let's call, for example, x equals sum, and let's give the first parameter 10 and the second parameter 20. And here, let's show the message to the console. The sum of 10 and 20 is x. So this is very simple. This is how we use functions in Kotlin. So now we have another kind of functions, higher order functions. So basically, a higher order function is a function that takes another function as parameter and or return value. In our case here, we have the two parameters are an ordinary parameters, just values. So a higher order function is a function as parameter or as a return value. Let's create another function. Let's call it discount. Or let's call it, for example, total price. Here we will put the first parameter, initial price. Let's call it price of type double. And now we're going to introduce the higher order function. So discount is going to be the higher order function or anonymous function. In our case, we have So how to declare a higher order function? Open the parentheses and use the symbol followed by the result type. So inside the parentheses, we have the parameters that this higher order function will take. For example, if our higher order function will take integers, we put here an integer. And if our higher order function will take, for example, a string, let's put here a string, and so on. In our case, we're not going to need the results or a parameter in our higher order function. And here we have, again, two conditions or two cases. If our higher order function is going to return nothing or void, we're going to put here units. Otherwise, we're going to put the data type that our higher order function will return. In our case, it's going to return a double. So discount, we call discount a higher order function. So let's return some results here. And of course, we forgot here to put our results. It's going to be of type double. And here we're going to put price minus here price times discount. So this is just a normal function. And how to use this higher order function? Let's say here, for example, val total price. This is total price. It's just a variable. Don't confuse total price variable with total price function. Anyway, let's remove this confusion. Let's change the name to total price. It's gonna be the total price function, and the price, let's give it 299.99, and the discount, it's gonna be a lambda or a higher order function. So it has to return a value, and the last statement, it has to be a double value. So the last statement that we're going to put here is 0.25. So, and here again, let's print the results. The total price after discount is TP. And let's execute our function, and it's going to do the computation for us. So total price after discount is 224.9925. Another type of functions in Kotlin, which are lambda function. So a lambda function is a function that has no name, and it's defined by using just the curly braces. So we're now going to use the keyword fun, in this case, to create a lambda function. Let's take, for example, the following lambda function. Let's call it val, and let's call right now we're going to write here is just the name of our lambda function. Character char count equals, and now we're going to open the curly braces. Now we are inside the lambda function. So the parameters, the first parameter that's gonna have is, let's call it str, stands for string. The type of parameter is string, and the return value or the core is gonna be of course the parameter string. And let's apply the property length. So the char count, it's a function that's going to count how many characters inside a string. And basically how to do a lambda function. This is the name of our function. We open the curly braces, and inside the curly braces we put our parameters. The first parameter, we need one parameter. We're going to call it string, str of type string, and here stands for the return value, and the last statement, it's going to be our return value of type int, which is the string point, the length. So the length is just a property of the string str object. So how to use our lambda function? Simply here, let's call, for example, another value is tr count equals. Now char count is going to be, as we're going to use char count the same as we used the other functions before. So char count, open the parentheses, and let's put here our string. Simply, let's say hello. And here, let's print to the console the results. The char count of hello is str count. So it's gonna give us, of course, 1, 2, 3, 4, 5 characters. So this is how to use lambda functions. So if you are not willing to write the keyword function fun followed by this normal syntax, you can use the lambda function to create your functions. Another type of functions, are inline functions. So what is an inline function? An inline function are often used to enhance the performance of a higher order function. The compiler will copy its parameter, aka the function, to when it's called. So we use an inline function when we have, when we are dealing with a higher order function. In our case here, the discount is a higher order function. So in order to enhance the performance of this higher order function, we're going to use here the keyword inline. So what does this mean? Here, in Kotlin, everything is an object. Even the total price function is an object itself. So what does this mean? If it's an object or not, the compiler will reserve a memory space for that object. So maybe if we have a heavy task that higher order function is doing, we need to enhance its performance by using the inline keyword, so that the compiler will just copy the content of that functions inside without reserving any space or memory space. I'm going to write another function to keep it simple. So let's call it inline, of course. And if you are using here, let's say here in sum, using the inline keyword, it's going to not complain about, but it's going to tell you that, hey, you don't need actually to use this keyword because it doesn't do anything. That's what actually our IDE is telling us. Expects performance impact from inline is insignificant. So the keyword doesn't mean anything here. But when we are dealing with higher order functions, then we can use the inline keyword to enhance the performance of the higher order function. So let's write an example. Let's use keyword inline followed by fun, and let's call it, for example, let's say some function. It's going to have of course, one parameter of type higher order function. Let's call it here function. It's going to be, that's any parameters, and it's going to be a void of type unit. So let's print a message here before. Let's call here the function, and let's print another message after. So what the compiler do in this case? What the compiler will do in this case? It will copy the content of this function. It's called here. So anything that we have put inside this higher order function, it will copy its content and it will put it inside here without reserving any space. That's why any memory space. That's why we can, or the compiler will enhance the performance of this higher order function. So if we didn't do inline keyword, the compiler will reserve a memory space for this object of name function. So that's why we're going to tell the compiler, hey, don't reserve any memory space, just copy paste the contents of the higher order function and put it here in this placeholder. So that's what the compiler is doing. So now the use of this higher order function is going to be very easy. So we called it sum function, and here we will print inline function content here. So let's assume that this kind of or this code, it's a very heavy code or a heavy task that we are performing. Right now we are introducing the inline keyword to this higher order function. The compiler will not, as I said, reserve much memory space to this task. It will just copy this print line that we have done here, or we have wrote here. It will copy it and it will paste it here. Simple as that. So as I said, the inline keyword, of course, it will prevent to create the object function. Right now, we're going to see another aspect of Kotlin is the oriented objects programming side of Kotlin, which is basically the use of classes and objects to handle our data. So basically, a class is a blueprint for an object that defines a template to create this object. And the object itself is instantiation of the class. In order to create a class in Kotlin, right-click on the Kotlin folder and choose the Kotlin class. Let's name it vehicle. So the class vehicle is now empty, and this is the basic syntax of any class in Kotlin. The top section of the class is called header. So in header of the class, we find the constructor. And what does it mean? A constructor is a special member function invoked when the object is instantiated. And what it does, it initializes the properties. So in our case, we will need some properties in class vehicle. And in order to create the primary constructor, after the name of the class, open the parentheses, and inside the parentheses, we will put our properties. So let's write our first property. It's going to be a public property. And let's choose a brand name of the vehicle of type string and the price of the vehicle of type double. So those are a public properties. So what does it mean, a public properties? Those are properties that can be accessible everywhere in our program when we will initialize our class or our objects. We can control also the visibility of the properties by putting before the val keyword the private keyword. So now the brand name is private to this class. We cannot access the brand name property outside this class. So let's see this in action. So our class basically right now doesn't do anything. Let's come back to the main file. And the operation that I'm gonna do right now, it's called instantiation of the objects. Val car equal vehicle. And here we open the parentheses. So the operation of equal is basically the instantiation of creating an object. So we are using the constructor to construct our object's car. So concerning the visibility that we talked before, let's tap car, and to access the different members of the class vehicle or methods, we need to type the dot point after the car objects. And we can see here only the price property, because by default in Kotlin, the public everything is public. This class is public, and also this property price is public as well. So in order to create our object, we need to provide some dependencies. Those properties are dependencies. What does it mean? In order to create the vehicle class, we need to provide the brand name and the price. Let's remove the private property right now, and here let's say I prefer to do the named properties. So type brand name equal some brand, and the price equal let's do, for example, 15 grand. And of course we can see both properties because by default the price and the brand name are public. So to recap, to control the visibility of anything in the class, we need to use the modifier property modifier of visibility, or to control visibility, private or public. Public is by default, and we have private, and also we have protected. I'm not gonna talk about protected right now. We will talk about protected when we will see the inheritance aspects. So this is the constructor vehicle, and inside the class, or inside the curly braces, we have the core of our class. We can find in the core of the class a special method called init. So the init method is used to initialize the properties or the local variables in a class. So in our case, we don't need to initialize anything. Let's put here just a comment, init properties or vars. In the class also we have something called methods, and methods are just the functions inside the class. Let's write a method, a public method for the class vehicle. Let's call it, for example, apply discount. This method is going to take in parameter an amount of the discount to be applied, and it will return a double value, so the discount after the price after the discount. So it will return basically the price minus price time the amount. So this is a public method, and we can see the public method when we type car dot, and we have the apply discount because it's a public method. To control the visibility, of course, of the public method, we can make it exclusive for the class vehicle by adding the keyword private, and here we cannot access no longer the method apply discount. So I hope you understand the concept of private and public, and we'll see, as I said, the protected modifier. Let's create another function. It's gonna be here a private function. It's pretty simple. It's first char to uppercase. So what it does, it will transform the first uppercase of a string to uppercase, and the rest with a normal case, whether uppercase or lowercase. So first char to uppercase, it's going to take in parameter a text of type string, and it will return a string object. So it will return the following string. If the text is empty, so why we test the text is empty or not? Because we need to access the first character to transform it to uppercase. So if the text is empty, we will return an empty string. Otherwise, we will take the first character, because we have a non-empty string. At least the string will have one character, and let's transform it to uppercase. We have a special method called uppercase already coded for us in the standard library of Kotlin, and we will concatenate or join the other part of the string that we have. So we will join the other part of the string, which is the substring of the starting index will be the index 1. So, for example, if we have brand as a string, it will take the first string and it will transform it to uppercase, and it will add the rest of the string, which is R, A, and D, to the word brand. So this is the basic algorithm. So right now we have seen the methods of the class, and we have something a special methods in Kotlin called getters and setters. So basically a getter and setter are special methods that allow us to get and set values to properties. Let's create a property here, and let's call it tag. It's gonna be of type string. Let's initialize with an empty string. So in order to create the getter, simply type the getter function, and let's assign it to the field. The field is a special variable that will return the value of the tag property. So let's do some transformation to this getter. For example, it will get the tag, but let's apply the function that we have created. First character to uppercase, text equal the field, and the variable field, it returns the value of tag. And the other special method is called the setter. So the setter basically is a method that sets or assign a value to that specific property. So choose the setter method, and inside this method we will assign, or we will fill the property tag with some data. So let's put, for example, if the user provides an empty string, if the value that has been provided is an empty string, we will set the value to a default value, for example, this special tag. So this is basically everything you're going to need. You're going to need in a simple class in Kotlin. So what does it mean, inheritance? Inheritance is the ability to acquire the members, aka methods and properties, of another class. So without copy pasting all the properties, all the class to the properties and the methods to another class, we can use this technique of inheritance. So in Kotlin, by default, a class is, for example, this class vehicle can inherit from the any class. The any class is a generic class. It's the super class. So, and in order to make our class inheritable, we need to use the keyword open, then class and vehicle. So what does this mean? Our class right now are open for inheritance. Let's create a new class. Let's call it bus. So to inherit from the class vehicle, simply after the name of the class, add colon, and let's type the vehicle. So we need to fill inside the constructor of the class vehicle the brand name and the brand name and the price. So let's declare here the brand name of type string and the price also of type double. So we will provide those dependencies. So brand name equals brand name, and the price equal price. So right now, if we create an object in the main file bus equal bus, let's give it the brand name equal some brand of bus, and the price will be a little bit expensive. Let's say in the bus, the object can have the same properties and the same methods, available methods, without copy pasting. So we didn't put anything yet inside the core of the bus, but we have also available methods that's been inherited from the previous class of the parent class vehicle. So this is why we use inheritance, because it's very helpful. It will allow our code to be more readable and more reusable. Let's create a simple function here. Let's call it show details. It will only print a simple message, bus details. Right now we're going to see how we can use the protected keyword or the protected modifier. So the protected modifier will allow us to acquire only the properties during the inheritance. So if we change here the first character to uppercase to protected, here we can use it, for example, in our case. Let's say value details. Let's give it this specific string. And here we will do details. First chart to uppercase, and the text will be the details. So right now we are able to access the first to uppercase method. And if we change here the protected to private, we won't be able to use this method, because it's only private to this class. So this is why we use protected. So we have in the top by default the public, and it's come in second level protected. So protected will be used only for the class that inherits from this class, and private is exclusively for this class. An abstract class is a class that can't be instantiated, so we cannot create an object from this abstract class. Let's create an abstract class by right click. Let's choose Kotlin class, and here we have, let's type the car class, for example. And in order to make this class abstract, simply add abstract keyword followed by class and car. The car class will have a private property. Let's call it the name of the class, and in the core of the class, let's create a simple function, show name of car, for example. It will simply print to the console the following message: the name of the car is $, and name. And we will provide also an abstract method. So the abstract method or abstract function, we won't have any car inside. So just the header of the function. Let's call it show drive train, whether rear wheel drive or all wheel drive or front wheel drive. So this is a generic declaration we have. For this example, we have a car, which is the parent class, and we will create other types of cars. We can have rear wheel drive cars, we will have all wheel drive cars, and we will have front wheel drive cars. So let's create a class. Let's call it rear wheel drive car. So we will inherit from the class car, and we also need to implement its methods. So in order to implement the methods here, of course we have to add the name as a string because it's a dependency. And let's put here the name equals name. And we need to implement the abstract method. So only we have one member, which is show drivetrain. So the keyword override means that we will implement this method. We can implement it however we want. Here we will override the behavior of the show drivetrain function. We will put simply here this car is rear wheel drive. We will create another class. Let's call it, for example, all-wheel drive. It will have the name, and it will inherit from the car class. Let's give the dependency name equal name, and we will implement the abstract method show drivetrain. So another implementation. So here we will put this car is all-wheel drive. So basically, this is how we use inheritance. And of course, we can access the function show name of car everywhere because it's a public function. So in our main file, let's create the value rear wheel drive car equal rear wheel drive. Let's call it, give it a name 1, and the other one all wheel drive equal all-wheel drive. All-wheel drive. We didn't put the name car, but it's okay. Equals name 2. And let's show the type of each car. Show the name of car. All-wheel drive. Show the name of car. And here we will drive. Show drivetrain and all-wheel drive also. Show its drivetrain. After execution of the program, we have the name of the car is name 1 and name 2. And here it's the implementation of the first show drivetrain for the class rear-wheel drive car. And this is the second implementation of the all-wheel drive car. So this is how we use the abstract aspects or abstract technique in order to avoid code duplication, in order to make also our code shorter, and of course it will allow us to make our code reusable. So let's get rid of the whole thing, and let's delete the car and the rear-wheel drive classes. Yes, that's it. So another aspect that we will see is interfaces. Show interface. Interfaces can't contain any state. It's like defining rules that the implementing class should respect. So as we have seen before in the abstract class, we can have some kind of state, but in interface we cannot. So interface is basically does pretty much or respects the same thing as the abstract classes. If we talked about how to make our code reusable and to prevent or avoid code duplication and make our code shorter, it falls in the same category. So in order to create an interface, right-click, choose Kotlin class and choose interface. Let's name it, for example, pager. So in this class pager, we will have only the declaration of the functions that we have. We are not allowed to do any state here whatsoever. So let's create 4 methods. Let's say function current page. It will return an integer. Another function pager size. It will contain it will return an integer, and another function. It will navigate to next page. So it will give us the list of, let's say, for example, of strings, and previous. It will navigate back to the previous page. So it will return the same type as a list of string. So you have to respect those rules in order to implement this interface. So as I said, we use interfaces in order to, first of all, our code shorter, avoid code duplication, make our code reusable. So let's implement this pager. Let's create another class and let's call it simple pager. So the simple pager class will implement the pager interface. So I'm gonna give you a small shortcut. In Windows, press Alt and enter, and it will give you this context menu, and choose implement members, and we will implement all members. In our case, the simple pager will have a private value data. It will be a list of string. So this is our simple pager class. So we will now implement the pager class. Let's create a variable here, a private variable. It will give us the current page. Type integer, let's give it the value 1. So the current page, it will give us the current page variable. It will return current page. Pager size will return the data, the size of the data, and the next page, which means the next list of string, we will increment the current page, and we will return the data of current page -1. Why -1? Because to avoid the index out of bound exception. And also the previous page, we will decrement by 1 the current page, and we will return the data of the current page -1. So this is the simple pager implementation of the pager class. So let's create, to see if our class is working fine, let's create an object. Let's call it ASP, simple pager, and let's instantiate our object. It's gonna be the data, of course, are lists of lists. So first it will be a list of, and I have prepared this in advance. This is the first page. The first list is the first page. The second list is the second page, and the third list is the third page. So let's see different methods available for us. So we have the current page, we have the pager size, and we have next and previous. Let's show, for example, the pager size is, so dollar open the curly braces and ASP dot pager size. Let's navigate to the next page, ASP dot next, and let's show, for example, the current data or the current page. The current page is curly braces ASP dot current page, and let's print the current data. Current data without curly braces this time, and we are good to go. So as we can see in the output of the compilation, we have the pager size is 3. I missed here, is 3, because we have 3 lists. The current page after navigating to the next page is 2, and we have the current data after navigating to the next page is data 4, 5, and 6. This is basically how to use interfaces, and we're going to use interfaces a lot in the upcoming videos. Now another special class in Kotlin, which are data classes. So data classes are basically a class that only hold data and does not provide any functionality. So in order to create a data class, right click, choose Kotlin class, and choose here a data class. Let's call it, for example, person. So the class person will have first and last name of type string and an age of type integer. So this is the data class, and as we said before, it's only encapsulates the data and does not provide any logic inside the class, which is very useful. We're going to work with the data class in the upcoming video, when we're going to talk about the MVVM architecture and the different layers in our applications. Right now we'll see special classes in Kotlin, which are sealed classes. What does it mean, a sealed class? So a sealed class is a class that serves the purpose of representing a restricted class hierarchy, allowing us developers to maintain a data type of a predefined type, except that nothing else is able to implement this sealed class. So you will understand what I've said right now in this particular example. So let's create a class, and let's choose here sealed class. So the sealed class that we're going to create is pretty simple, and it's just a snapshot of the class that we are going to use as a helper class in the upcoming video, which is very helpful when we are going to deal with API calls and how to deal with the states of an API call. So it's gonna be called API results. So the sealed class API result will contain two objects. The first one is the success case, in case of the API is made a successful call, and the other one is the failure or the error case. In case of an error, it will return, of course, it has to say the type of result. So we've said in the definition that the sealed class, nothing can implement this sealed class. So if we try, for example, to create a class and try to implement this sealed class, the compiler is complaining, and the error that's given us sealed subclass has no states and no overriding equal. So we cannot override or implement the sealed class. Let's come back to the simple pager and let's add the function here in order just to create or to mimic the API call in our class. Let's create a function. Let's call it get data from API, and it will give us an API result. So how to use the sealed class? It will return an API result if the data are empty. Let's return an API result of type an error of type API result. Otherwise, let's do here curly braces, and otherwise it will return a success. And to work with this example, we will use the when control control flow states. So file pager equals let's come back to that simple pager that we have done before, and let's put here API result val API state equal let's say sp dot get data from the API. So if when API state, in case of error, API result that's error, we will show the message API error. In case of API that's success, we will show the message bingo, we have some data. Of course, if we execute this code, we will have bingo, we have some data, because the data are not the data, we have some kind of data in our example. So I've just recreated the vehicle class, and now we're going to talk about a very important technique in Kotlin, which is extension. So what does it mean, an extension? An extension is the ability to add a functionality to a class without using inheritance. So in our case, for example, we have this function first character to uppercase, which transforms the first character to uppercase. We can use it as public or private, no problem. Now, in order to create an extension, it's just a file. Let's create a new file here, and let's call it choose file. Just give it a name, extension. It doesn't have to be the name extension, just a name. You can choose whatever name. You can make it or name it string extension or object extension. In my case, just name it extension. So in the file extension, in order to create the extension function, we need, of course, the keyword fun, and we have to put the object in which we're going to apply this extension. So the object that I will need in my case is a string. I'm going to work on string, so the extension will be on string. So string and dot. So this is the first part of the syntax, and then we will write the name of the function. Let's call it. Let's give it just the same name here. Let's copy this name and paste it here. And it will work the same logic as before. So it won't take anything in parameters, but it will return a string. So the data that we will work on, we can access its properties with the keyword this, because we are inside the class or the class string. So just keep this in mind. So it's gonna be pretty much the same logic as before. We're going to copy this and paste it here, and we will change a few things. We don't have the parameter text, but we have this keyword, which references the current objects that we are working with. We can get rid of this, of course, because we don't need it. And here in our case, we will change the text with this because, as I said, we are working on the current text. So the current text is referenced by this. So we can do here without this. Only we need this because in our case, we need to access the first character. So by accessing the first character, we need the index. The index is 0. So we will need the this variable or the this reference and the 0 index. So we created right now the first function, the first extension of the string. As I said before, we did not inherit anything from the string class, but we extended the functionality of strings, and we added a new class, a new function in the string class. In order to see this in action, let's get rid of all of this and create a simple string. Let's call it name. Let's give it the value Mike. And let's print the name. So name, and we can see here the available methods by default in the standard library of Kotlin, and we can see here also our extension method first char to uppercase. We have made a very small typo here. Let's remove the T here. So name dot first character to uppercase. So it's also available for us to use without inheriting or creating a class, and inside that class we will put methods. So this is very helpful in order to make our code shorter. Usually the extensions are we put them in a separate files for just a helper functions that serves that sole purpose. So if we execute our program, of course, it's going to give us the Mike uppercased as its first character. We can also create another extension function on, so remember this, an extension function on an object. So the object we will use the extension function for is the vehicle class. Details, let's not name it details, and we will just print the message, the vehicle and let's give the tag, let's access, for example, the tag. So we have the tag, it's also available, and the brand name. Oh, brand name. So without extending anything or creating another class that will give us the functionality, this functionality, we are just using the extension technique to do so. So it's the same as before. Value car. Let's give it, for example, the brand name, some brand. And the price 50 grand, something. This is too much. Okay, and let's do, for example, car dot details, and we can see right now the result of the car details. So, as I said, the extensions are very useful when it comes to make our code cleaner and to create helper functions. So let's talk about an important subject in Kotlin, which is exceptions. So an exception is a technique allowing our app to handle error at runtime. So why we need to handle error at runtime, you might ask. If we did not do so, our app will crash every time there is an exception. Let's create a very obvious exception. Let's give the 0 to 0, and let's call the value 1. Give it the value 1. Obviously, we cannot do this kind of operation. We cannot divide 1 by 0. If we execute this program, we will have the following exception. So we have an exception in the thread main. We cannot divide something by 0. So the kind of exception is arithmetic exception. And in the real world, in the real application, the application will crash. So in order to avoid this kind of behavior in our application, we need to handle the exception correctly. So in order to handle the exception correctly, we're going to use the try-catch block. So the try-catch block consists of doing our exception. So inside this try, we put the code that we suspect maybe we will have an exception in this code. So the code that we need to handle is 1 divided by 0. So 1 divided by 0. And in case of the exception occur, let's, for example, show the following message. You cannot do this. So it's the same thing, but there is only one difference. Our application won't crash because we handled the exception correctly. You cannot do this. We show to the user the error that's occurred, and our application will always work fine. So our application won't crash. That's why we need to handle our exceptions in our code. So exceptions are very important. So right now we're going to see the scope functions. Scope functions are special functions in the Kotlin standard library. Those functions are predefined, and it will allow us to execute a block of code within the context of the object without its name. So the scope function are let, run, with, apply, and also. So in the sake of this example, I have prepared 2 classes. So nothing fancy here, just the first class is for user, and we override the toString method to give us this representation of the class user. And the remote connection is a simple class that have one public method showing the following message: encrypting connection. So the first scope function is let. So let function, the context object is the identifier it, and the return value is the lambda result. Let's create the user object. So it's gonna be user, and it's gonna have a name Mike, age equal 18, and address, it will be some address. I have to mention that the properties address is nullable, so it can be null and it can't be null. So what does it mean? You can provide the address or you cannot provide the address. The compiler won't complain. So in our case, we provided the address. And basically, when we use the let scope function, we use let for non-null values when performing some actions. So let's perform an action on the property address. So the address, maybe it's gonna be null and maybe it's not. So instead of doing this kind of syntax, if user dot address is not null, we will print the following message: address is dollar curly braces user dot address. Instead of doing this, we can achieve the same result while operating on the non-null values. We can do user dot address, and we will, because it's a nullable property, we need to add the question mark sign, because we are dealing with a nullable value. Those are one of the strongest characteristics of Kotlin, which is null safety operator. And point let. So here, as we said before, the context object is it, as shown here in the proposition, and it's gonna give us the lambda result as a return value. So the return value will be, for example, result. And here we will not print the message. Let's just leave, or let's introduce or put a string value here. Address is simply put it here, because as we said before, the context object is it, so the value of the address is referenced by the identifier it. And here we can print the result, and basically it's gonna give us the address is. So this is the main use of the let function. So address is some address. So basically, to recap, we use let when we are dealing with nullable properties or nullable values. So we want to avoid the null pointer exception. So the second scope function is with. In with, the object is passed as an argument, and the return value is a lambda function. We usually use with for calling methods on an object without providing the return value. So we can do both ways. The first option is whether to do with. Okay, sorry, here we have to put what's going on. So here it will be the user object as parameter, access here the name and the age and the address. So, or without using this, you can achieve the same result as well. So basically it's this as the identifier to access the object context. And let's print here the following message: user is name. And we can achieve the same result by doing so. Val username equal with, and of course we need to pass the object in parameter, and instead of doing print, because we are assigning a value to the value username, it will be just a string user is name. It's pretty much it's going to give us the same thing, and here we will print the username. So this is basically how we use the with scope function. It's printed twice because we used both, but I prefer the second option. So the third scope function is run. We usually use run when changing the properties of objects when the lambda contains the initialization and computation. It's basically a combination of let and with. So let's see the following example. First of all, let's create an object here. Let's name it connection. So we will assign a value details to the following statements. So connection point URL, point run. So as highlighted here, we have this as a context object is this as a receiver, and the return value is a lambda result. So the lambda result here, it's gonna be the message encrypts connection. And of course we can change here the property port. Let's give it, for example, the 8080 value. Let's print the details. Another scenario to use the run function. As we said before, run is the combination of with and let. So basically we can use it as we did with let scope function to perform operation on nullable objects. Let's create, for the sake of this example, an object user2. Here we can do the same thing as we did before. Val result equal user2 and run. So let's assume that for some reason the user2 is null. So let's assume that the user2 is null. So in order to avoid null pointer exception, we can use the scope function run. Inside the run, we can access the properties of the user. Let's say, for example, here user name is, it's gonna be name. And let's print the result. So after printing the result, it's gonna give us username is the name that we have provided. So let's delete all of this. Let's delete the user2. So let's jump to the fourth scope function, apply. So apply, we usually use apply to operate on properties as configuration technique. So the context of the object is a receiver, and the return value is the object itself. So let's make some minor changes here. Let's make the age is nullable as well, and let's give it the value null. And let's create another, or let's delete this code, and we can do as follow: user dot apply. Here we can configure the other properties that we didn't specify and we didn't assign the values to in the first instantiation. So the rest of the properties are age and address. And of course, we need to change the type of age to variable and the address as a variable. So age equal to, let's give it 18, and the address, let's give it some address. And as we said before, the return value is the object itself. So it's going to give us an object. Let's put here an object, complete object, for example. and let's print that object. I didn't like this name, configured user. And let's assign here, let's print the configured user object, and basically it's gonna give us the details that we have, the overridden string. The user is Mike and age is 18. So this is how we use apply. So last but not least, the also scope function. So to avoid shadowing this keyword from an outer space, we use also. And to apply action on an object as an argument, we can use also. So those are the two main reasons why to choose the also scope function. And the context object is the argument, and the return value is the object itself. So let's create a variable here. Let's call it user name uppercase, and to use also, as we said before, use user point also. Let's print the details of the user, and here, as we said in the definition, the return value is the object itself, so we can use the properties of the user objects. So the property that I want here is the name, and of course we can apply to it the first character to uppercase, and let's print the new uppercase name. So it's gonna give us first of all the details of the user. So the user is Mike, age 18, and it's gonna give us because here again username uppercase is string. It's this transformation that we have applied here, and we will print it to the console. Now we got all we need to build our application. In the second part of this video, you will learn how to build your Android application using Jetpack Compose and MVVM architecture. I hope I was helpful, and see you in the next one. Bye bye.